Hello guys, welcome back to my YouTube channel. I am Praveen Reddy. So in this today's class we are going to write the behavioral model programming for the AND gate. So already I have given the module name. I have taken the input AB, output is the C. The same thing I am going to represent in the line number 24. Input ABR, declaration of the inputs to the ports, sorry, input ports to the module. So by using output keyword we are going to declare the C as the output module. So if you don't understand what I am trying to tell here, so in the previous classes I have explained it. Please try to watch those videos so that you will be understanding clearly. Right, so just I'm going to give the module declaration. So in behavioral model, remember one more thing, for output we need to write the register keyword also. We can write something like this: output space register space C, or you can write something like this: output C, then end of the statement, then register C, end of the statement. See that what I'm trying to type here, you can observe here. In behavioral model, always output variable should be given to the register, something like it is going to perform the storing kind of the operation. You will understand exact meaning when we are going to discuss about the sequential logic circuit. So out of 4 levels of modeling style, now for writing the AND gate program, Verilog program, I am going to use the behavioral model. Right, so as per the behavioral model, remember one very important point is that later on we'll discuss. So in the line number 28 we are writing the statement is always at the rate of A or B. So what is the meaning of this one is that, so in procedural statement, always is the procedural statement. Inside of the procedural statement we are writing something A or B. It means that whenever either A value or B value changes, you execute the following statements based on the inputs either A or B. So we are only considering the input, not the output variable. Based on the A or B, just to execute the following statements. So always we need to represent with the always block in case if you are writing the program with the behavioral model. So what we have to use is always at the rate of, in bracket we need to write the input ports A or B. So for generating AND gate I have the AB are the input ports. Now see that one thing, if you want to write the Verilog program in terms of the behavioral model, first we need to understand the truth table. As per AND gate truth table, the unique combination is that if both inputs are set to be high, output equal to 1. Based on that simple logic, we are going to write the behavioral model representation. See that in line number 24, I wrote something like this: if A double equal to 1 tick P1. There first we will understand what is the meaning of 1 tick P1. So first leftmost side 1 is there, right? That is meaning that 1 bit representation. Next after tick we have the B, right? B means it is the binary representation. After B we have the 1, right? That means is that the value is 1. We know that binary value either it may be 0 or 1, right? That value is the 1. So what is the meaning of 1 tick B1 means 1 bit representation. B means binary number. That 1 bit representation value is the 1. If I am writing something 1 tick B0 means 1 bit representation, binary value is the 0. If you are finding something difficulty here, directly you can write A double equal to 1. See here, double equal to is the equality operator. So that operators you need to understand in Verilog whenever you are going to write the program by using of the Verilog language. Right, then only that can be understood by the Verilog. Right, that's point to be noted here. Now here what exactly I am trying to say here is that if A equal to 1, B equal to 1, then you display the output C equal to 1. That means that in AND gate logic, if both inputs are set to be high, output equal to 1. Else output is what? 0. That's what. So if you are writing the program in terms of just truth table logic, that is what we called as the behavioral modeling. And remember, the beauty of the behavioral model is that even though if you don't know how to, what is the symbol of the AND gate and you don't know what is the logic expression for the AND gate, that all absolutely not required. If you know that logic, yeah, then you can do the magic in the behavioral modeling. See, in case of data flow modeling, what is required? We required logic circuit. From that logic circuit, we required the output expression, right? Here we don't require anything. Only truth table is sufficient to write the program. Now here remember one more point. After if statement, If A equal to 1, B equal to 1 means what is the expected output? Output equal to 1, right? If both inputs are 1. So here we are going to write C equal to 1. You can write C equal to 1 or C equal to 1 tick B1. 1 bit binary representation. That binary value is the 1. So then one more point to be remember here, in case if you are writing the program in terms of the Verilog, that point is that so after if statement we are not going to write the output directly, right? So before that what we are going to do is that we are going to use the something called as the begin end statement. After writing the begin statement we are going to write the what is the expected output value. Once that output value is completed, now we are going to complete the statement, nothing but the closing with the end statement. In between begin and end only we are writing our output value. See, if both in as per the line number 29, what is the if condition? If both inputs set high, then output equal to 1. That is nothing but C equal to 1 tick B1, or you can write the 1 only, no problem, both will be same. See that in line number 32 we have only single equal. In line number 22 we have the double equal operator. It means that when you are combining and when you are going to discuss A equal to 1 with the B equal to 1, there we required equality operator. But in case of line number 32, just we are we are producing the output, right? So for that we don't require for the equality operator. That point to be remembered. See that in begin and statement, in between that I am going to write the C equal to 1 or 1 tick B1. Now this is one possibility as per the truth table of the AND gate, right? So if this condition is not met or satisfied, then what should be the output value? 0, right? So after if condition, the next condition is that else condition. So in line number 34 we are going to write the else condition. So else means what is the expected output? C equal to 0, right? Either you can write the C equal to 0 or 1 tick B1 or B0. Here it is important. If you understand what is the answer here, 1 tick B0. 1 bit representation, B means binary number system, 0 means the value is the 0. Right? If you want to write, you can write in between begin and end statement also for writing the C equal to 0 or 1 tick B0. Right? So if this condition is not satisfied, then you execute the following condition. That is what exactly we are saying the how behavioral model is works. Right? Remember in combinational logic circuit most of the time we might not be using the behavioral model, but the moment and here we are going to use either data flow model or gate level model. But remember that the moment you are going for the sequential logic circuit, you cannot able to write something in terms of the data flow or gate level modeling, which is much difficult for us to write the program, right? So we are always going for the behavioral model. So now what exactly done? After saving the program, I am running on the RTL schematic. You can see the RTL analysis on the left side. Click on the schematic. So now open elaborated design is running. So once it is done, you will be getting the output. The output is AND gate in terms of the what? Behavioral model. See, in the previous classes also we have seen the same diagram. The way of writing model is different. Now what exactly I am doing? Click on simulation sources. For that I am going to add the source. Now I am going to write the test cases, right? So what we have to do? Simulation source. In order to write the test case we require the file. So just click on the create file, give name, but remember that we have the some rules and regulation if you are writing the file name. Here I am not going to discuss. You just go through once in Google or somewhere what are the rules and regulation we need to obey in order to write the file name. If we give something some numerical number, it won't accept, right? Just read those statements. So once it is completed, then click on finish. Now what exactly we are going to do is that here I am not going to assign the port externally. In the program itself I'm going to give the ports. So just I skipped that statement. So just here we have the click on the test bench, right? So AND gate behavioral model, for that we have attached the test bench. So here the test bench that we are going to write whatever the test bench we have written for the data flow model as well as the gate level model, right? So we have explained the same thing multiple times, so I'm not going to explain the procedure again and again. So if you don't know how to write the test bench, why AB register, why output equal to in terms of the y, please try to watch the previous video. Nothing either you can watch the all logic gates video a data flow model or gate level model video, so that you can understand how we are going to write the test bench operation. I hope you understand and this video helpful for you at somehow. So if you like my video, please do like, then subscribe, and please try to share. Thank you for your patience. Thank you very much. So just I'm going to play the remaining procedure. So I'm not going to explain what is going to be happening. I hope you will understand. Just I'm giving the test what is happening everywhere. I hope you understand. Thank you very much, guys. Have a good day.